Okay?
Cut that.
Oh, we have objects flying through the air here. Looks like peanuts. This looks like Dodger Stadium, right? You buy the peanuts at Dodger Stadium and they throw them.
Oatmeal.
Oatmeal squares are so good though.
Oh, these are oatmeal
Oatmeal
squares.
squares.
Oatmeal squares, okay, well, that works too. Both are healthy. They're not Twinkies, you know.
I wish.
You wish. Okay, anyway, we have a homework assignment due today, and it sounds to me like I heard rumblings of the fact that you might need some help on some of these.
Yes, actually.
All right, what can I do for you?
Can we go over how to use the monotonicity?
Explain
Yes.
You said 4.3 and the other one at the same time.
I'm assuming they both imply.
Okay, hold on. Wait. Which one, okay, which one are we trying to prove?
P5.
P.5, post-condition rule?
How do you use monotonicity?
P.5, post-condition rule. Okay, so,
Don't you pull a rabbit out of the hat?
I don't think so. It's, well, okay, here's what I,
Definition of a Hor triple, right?
I did that.
it's, okay, what I recommend, P.5, let's take a look at it. P.5 monotonicity says, Hor triple Q, SA, precondition Q, statement S, postcondition A, and A implies R, implies Hor triple, precondition Q, statement S, postcondition R, right? I recommend that what you do is start with the left-hand side and get it to imply the right-hand side. So if you're going to start with the left-hand side, obviously the first thing you have to do is I mean, there's a Hor triple, right, on the left and a Hor triple on the right. Well, before you can do any manipulation, the first thing you got to do is what? Use the definition of the Hor triple, which is what?
P4.
Yeah, P.4. Yeah? So you got that? Okay. Well, look, now you've got Q implies weakest precondition dot S dot A, and A implies R.
Then you use monotonicity.
Yeah, you use monotonicity. Well, okay, the monotonicity that you use is 4.3.
I used one and then.
Hold on. Let's review. Yeah, I see. Yeah, we have to see how to use monotonicity. So let's go back and review 4.3. Here, let's bring it up. Yeah, this R. Yeah. So look, here's what monotonicity says. What monotonicity says is that if you know P implies Q, then what that tells you, what that implies, is that P and R implies Q and R. So you have an and here. What it says is that you can take, see, if you know that one of the conjuncts, if you have a conjunct, P and R. See, here's what this says. It says if you have a conjunct, P and R, and don't we? Are you with me? So this says if you have a conjunct, P and R, and if you know that this P implies something else, then this conjunct implies the same thing with the P replaced by what it implies. Are you with me? The way you use 4.3 is this. You say P and R implies by the fact that P implies Q, Q and R. Are you with me? This is how. Now, does everybody see how to use monotonicity? Oh, this is a really good exercise because it reviews. We've done this. We don't do it often, but when we do it, we really need it. But when we do need it, we really need to know how to use it. And this is yet another example of this. So do you see how to use? Do you see how we use monotonicity? It says what monotonicity says is that if you have a conjunct, and you know that one of the conjuncts implies another expression, then Q and then the thing that it implies, and you can replace this one conjunct with the thing that it implies, and the whole conjunct will imply the other conjunct with this one replaced by the one that it implies. Yes?
Can we replace Q as WP dot S dot A?
Those are
The A implies R is the thing that is going to imply.
Yeah.
The A, you see,
That's the R.
the
A implies R is the, no, it's.
No, it's the P.
But it's also the R.
So A is the P
The R
and
is the
R
Q
is the
implies-
Q.
Can we just do this one more, please?
Just like-
No, I'm not gonna write
Step.
it.
We
No,
already know to do the step because you gave us the hint. Let's just do that step on
As a
board.
clock.
Because I don't understand.
Either that one.
Okay, look. Okay, well, here, we'll leave this up. And now, what do we have at this point? We have Q implies weakest precondition dot S dot A.
Right.
We have,
And.
hold
A
on,
implies R.
we have Q implies weakest precondition dot
S dot A.
S dot A,
And
and A implies R. Are you with me?
Right.
Now, what does this say? This says that you can take, so here we have a conjunct, right?
Conjunct, and one of the conjuncts
I am claiming,
implies another thing.
I am claiming that if this implies something else, then this whole thing implies the same thing with that something else here. So this whole thing is like our little p.
Just do it.
I just said it. Can you not do that?
So
No, I
you
mean,
have that
that's
whole
what I
thing,
did.
and then you do and.
What? Yeah, hand me a blue pen.
'Cause you'll-
See, this whole, here, this whole thing is like our little p is like our little p here. See? Well, I mean,
Isn't it like
symmetry.
it's not like our P implies Q?
That's your P implies Q, is P3.
No, this is our p. This A implies R implies something, right?
Does the A imply R imply something, or is it,
Because
I mean, which is higher precedence, implication or conjunction?
P and implies Q.
Well, this is in parentheses.
With the R
Sure.
being the Q implies. Makes sense at all.
But you're saying A implies R implies something else?
Yeah, it does. Do you see what it does? Let's go up to, well, P.3 tells us what it implies.
That's your P implies Q bit.
Ho- P,
Okay.
P.3 tells us,
P implies Q.
P.3 tells us what it implies.
Sure.
Are you with me? That's why the hint is use P.3 and 4.3. P.3 tells us what A implies R. Implies.
Oh, cool. There's that one thing.
Are you with me on
You
this?
should write it down.
No, I want you can get this. You can get this. Q, look,
I got it, but it's easy to understand if it's on the board.
well, I know, but I don't want to do the homework for you. See, does everybody see that? Does everybody see that P.3 tells you what A implies R? Implies.
So you can do that in the same step then?
Well, we're using P.3 by virtue of the fact we know that this thing implies something else, and so by 4.3, the conjunct of this implies that. Implies that. Because if we replace this by what it implies, if we place one of the conjuncts by what it implies, then the conjunct implies that. Yes? I think this is the only way I know how to do it.
And you can have two things imply on your proof.
What do you
You can
mean,
imply-
two things?
You can imply as many times as you want, right?
Oh, yeah, right. You know, if A implies B and B implies C, then A implies C, that's transitivity.
Right,
And
but
it's
since we
mutually
already-
transitive.
Since we already implied something, you can apply another thing.
Yeah, you just can't, you can have any string of implies and equals, equivals, right? Because they're mutually, that's mutual
I have a
transitivity.
question about that.
mhm.
Relating to kind of last semester stuff with subsets.
Mhm.
Subsets are transitive.
Wait, what do you mean subsets? You mean if A is a subset of B and B is a subset of C, then A is a subset of C.
Yeah.
That's right,
So
subset,
can you use like you would implies on the
absolutely.
I watched the video from Thursday. Did you say that the max operator is an abelian monoid?
Actually, okay, there is a caveat there. The max operator is not quite an abelian monoid because it does not have a,
I
and identity.
But it works still?
Okay, so, hold on, okay, yeah, actually, yeah, I should have explained this before I just casually showed you that you could do it in that example. So the thing of it is that because it does not have an identity, you cannot use the empty range rule on it. And you cannot use it in any case where the range is empty, yeah.
Okay.
Yeah, so as long as you are careful to avoid that situation and know that that is meaningless, then the other properties hold and you can use it. So that was a very good question. And I was a bit cavalier about showing you that you could do that.
Yeah.
But I should have been more careful to point that out, that limitation out. Okay, so does everybody get this now? Are we good?
I didn't quite get your hint for P.8. Can't recall what.
Oh, it was the.
P dot eight?
Whether you put true in the precondition.
Okay, let's take a look at P.8. P.8 is, this is a messy one. It's got lots of Hor triples here. Q0S R, okay, Hor triple Q0S R0 and Hor triple Q1S R1 implies Hor triple Q0 and Q1, statement S, postcondition R0 and R1. So what I
I had no seen you use it back then.
okay, here's what I recommend. Here's what I recommend you do. I recommend you start with the right-hand side and get it to follow from the left-hand side. Okay. So now, if you're going to start with the right-hand side, you've got, because what you have on the right-hand side is you have this Hor triple with these conjuncts in the preconditions and postcondition. So obviously, the first thing you're going to do is what? Use what?
Hor triple.
Definition of a Hor triple, and you're going to get this to an implication, right? Well, now you have conjuncts. Now you have a conjunct in the postcondition. So what tells you how to do you have a conjunct in the WP.S dot, and then you have a conjunct. So obviously, what are you going to do then? Well, obviously, there's only one thing you can do. What? P.2, right? So that's conjunctivity, right? And now, here's our old friend. Who is our old friend to eliminate what implication means? 3.59. P implies, remember that? Isn't this great? We get to go back and use all that stuff that we learned and we didn't forget, right? So what was 3.59? It's P implies Q equivales, P implies Q equivales what? What was 3.59?
Not P.
Yeah, not P or Q. So what I recommend you do there is change that to not P or Q. Are you with me? So now what do you have? So it's not, what do you have in
Q and Q1.
Q0 and Q1? And so obviously you have a not in front of an conjunction. What do you do? De Morgan that, right? Is everybody clear? This gets kind of ugly, but you can do it. Yeah? De Morgan that. And
6 is the tricky bit.
and now you use the fact that OR distributes over AND, which is 3.45, and you have to write it all out. That's pretty ugly. Now, did I give you the hint of 3.76E?
Yes.
You just said to use it, but
Well, here's where you use it.
yeah.
You use 3.76E.
After De Morgan or after the?
After De Morgan. Yeah, after De Morgan. And actually, what you have to do is you have to use it twice.
You have to distribute over.
You actually have to use it twice because
You use 3.5 first.
here, let's write down 3.76E. 3.76E. Can somebody quote that for me? 3.76E. What is it? Is this one of the weakening strengthening ones?
Yeah.
Oh, sorry. Yeah, it's P and Q implies P and Q or R.
P and Q implies that parentheses. P and
Q or R.
P and parentheses. Is that what it is?
Q or R.
P and parentheses Q or R. So here's what happens. We have something in this form and we want to get it to follow from this. And what this says is that if you have a P and something or R, you can eliminate the or R, and if you eliminate the or R, then that will follow from this. Are you with me? So the trick is knowing which one you want to eliminate. Does everybody see what we're doing? We're saying this one follows from this. So the trick is, well, which one do you want to eliminate? Well, we have these two expressions. We have some expressions with Q zeros. We have some expressions with zeros and ones, right? We have one expression with a Q0 and a Q1 and an R0, and we have another expression with a Q0 and a Q1 and an R1. So what do we want to eliminate?
Q0 from the right.
Yeah, we want to eliminate one of them from each. So we need to
Twice.
yeah, and then once you do that, then you 359 it back again, and then definition of or triple back again, boom, boom, boom.
Do you distribute the Q0, the not Q0 or not Q1
Yeah.
over both sides, or
Yeah.
just one of them over both sides?
There's only one way to do it correctly. When you do or distributes over and you use 3.45,
Yeah, you do both.
you have to,
But since or doesn't have a precedence, can't you pick one?
no, you have to have parentheses to disambiguate. Anytime you have an ors and ands, you have to use parentheses to disambiguate.
Is that even a word?
Yep.
Disambiguate.
It's a logic term.
If
It's
you
a logic.
have Q0 or Q1 or, and then the expression, the Q0 and Q1 have to be in parentheses.
No, if you have ors, not if you have a sequence of ors.
Oh, that's what he was saying.
No, I think we were talking about ors and ands.
Well, the ands are in the parentheses.
we have the Q0 and or Q1 or the parentheses, WP blah 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 and WP blah blah blah.
Yeah, that's
Yeah,
before
you
we
do
distribute.
differences
Right, and so do you distribute both of the Qs?
there. Yeah, you do. You do.
Yes. Oh, I see what you're
You can
saying.
distribute
I see what you're saying. Yeah, you distribute the whole, yes, you distribute them both. Right. Yes, there was more than one way to distribute. You're right. But you want to distribute them both. Okay, well, these were good. These are good hints. It sounds like we're on track now. Okay. So let's continue on. Now today we are going to learn about the assignment statements. Now this is actually a little bit of a review because one of the things that we did in the very beginning of the course, at the very first few weeks of, actually I think the very first week of the semester last semester, we showed how how you can calculate the precondition when we introduced the concept of Hoare triple, and we used the assignment statement to show what the precondition of a Hoare triple, how you could calculate the precondition of a Hoare triple when you had an assignment statement. And then we used that. We had an exercise of. Do you remember that exercise? Remember, and it was basically just a practice in how to do textual substitution when we were first learning textual substitution. So anyway, the definition of the assignment statement is P.18. Now, because this is a definition, that means that it's not. We don't prove it, right? So let's look at what it says. It says if you have an assignment statement, X gets E. So capital E is an expression, and X is a variable. Yeah. And by the way, this is gets. This is not replaced by, right? Because what's the type of what's in parentheses here? What is its type?
It's assignment or like a.
It's a program statement. Yeah. So this is a program statement. What's the type of R?
Postcondition?
It's a postcondition. So its type must be Boolean. Yeah. Are you with me? So what this says is that the way you calculate the weakest precondition of statement X gets E postcondition R is you just take R, which is a Boolean expression, And everywhere there's an X, you replace it by E. And that's how you get the weakest precondition for that. All right?
Is the weakest precondition a Boolean too?
Yes, because the preconditions are Booleans, right? Preconditions and postconditions are both Booleans. Because the interpretation of the Hoare triple is if the precondition is what? True. Boolean. Okay? If it's true and you execute the statement, it will terminate and the postcondition is guaranteed to be true. So that's a Boolean.
And the whole thing is Boolean, or is it a program?
The whole Hoare triple, the whole Hoare triple is Boolean. It's either valid or not.
Okay.
So when we say, what does valid mean?
True in all states.
True in all states. Okay.
Okay. Because you'd never said what the WP was. That's what I was.
Well, yeah, actually, well, WP is a this is like a function, WP dot. You see what I mean? So it's how you calculate the weakest precondition. It's like a function that has two variables, a program statement and a Boolean, and then it returns a Boolean. That's what you can think of WP like that.
So would it be a function or a Boolean? Or both?
Well, it's a both. It's a function that returns type Boolean. So in a way, it's kind of like a what?
Predicate?
A predicate.
Is it a predicate?
Well, I never have heard it called a predicate. I suppose
Is that on a test? What is
That
it?
shows-
anything that we talk about in here now that it's public knowledge is fair game for the test. We should know all of these types, right? Keeping track of the types. I tell you, that is just so important. Clutch, is that the word? Okay, so anyway, so, and by the way, I'll have to say, I won't mention any names, you know who you are. After that big rant that I gave about what is the shape of a,
Or
of a specification, what's the first thing you write down? Curly brace,
Yeah,
already.
I didn't miss it.
Well, somebody did.
Oh,
So my rant,
did.
okay? Okay, so now so I want to do a couple of examples of P.18, okay? So here's our first example. Now, in this example, A and B are program statements, not rigid variables. A and B are program constants,
not rigid variable,
correct?
constant, not variable.
Yeah, so we have to distinguish between these. Not rigid variables. I'll do a couple of examples, and some examples we'll use rigid variables, and some we'll use constants. We might even use both in one, I don't remember, but we have to keep this in mind. Now, so here's what we're going to do. Whenever we have a program that we're dealing with, and we're trying to calculate like the weakest precondition, we're always going to give, because types are so important, we're going to specify what the types are. So we're going to say, here's what we're going to say. We're going to do it just like you do in C++ and Java. Okay, I had to decide whether we should do it like you do it in programming, or whether we should do it like :Z, you know, GCL. But I think because we're going to have constants, I think I'm going to use the Java style or C++ style. So okay, so here we go. So we're going to say int x y.
Are Java and C++ super close?
Oh, they're so
Yeah.
close. They are really. They're basically the same language, except for one important thing. Java has automatic garbage collection, so you don't have to do it manually. And then then they don't have explicit pointers, but everything in Java is a reference, so it's like everything is a pointer, even though there's no pointer types. And then you got the Java library, as opposed to the C++ libraries, possible libraries that you have. So anyway, we're going to say int xy, and we're going to say const int
You need a colon.
a.
Semicolon.
Well, you know,
Come on now.
const int
That won't.
AB, all right? Well, none of this is going to pop because this is GCL, all right? All right? And so now, let's say that the precondition, I'm just going to put P for the precondition, and here is going to be our assignment statements. We're going to say x gets x plus y, semicolon, y gets x minus y, and then the postcondition is going to be x equals big A, x equals big A, and y equals big B. All right? So does everybody understand what we have here? We're saying what the types of x and y are. We're saying that a and b are constant integers. Okay, so they're part of the program. And what we want to have, and then we're saying that the statements are going to be x gets x plus y, followed by, not simultaneous, but followed by, y gets x minus y. And then the post condition is going to be x equals a and y equals b. And our problem is we want to find the weakest precondition p. We want to find the weakest precondition. Yeah, that's what we're going to do. But what we have to do is, remember, this is one followed by the other. So we're going to have to do the weakest precondition of blah, blah, blah. Right, okay, so to find the weakest precondition, P, what do we do? So what's our notation for finding the weakest precondition of this with this? What do we WP dot, now what do we have? Yeah, x gets x plus y, semicolon, y gets x minus y, and then dot, and then what's this, right? X equals a and y equals b. Okay, so what's the first thing that we have to, what do we have to work with here?
So we want to take the post condition and do textual substitution in the statement.
So which one, which theorem, which previously proved theorem do we use? P point what? I don't see a skip here. What do we use? Ben, what do you think we use?
It's not on this page, is it?
I think it is. How are we going to break this? How are we going to break this down? How are we going to break this down?
Definition assignment.
14.
Yeah.
P18.
No, 14. Because 14 says how to do what? How to break it down. Are you with me? How to get it into, okay? Okay, so Ashley, you said P.14. So what does this equal by P.14? Okay, WP dot x gets, this one's x gets x plus y, okay. Dot, we'll just parenthesize this to make sure. WP dot what? Y gets x minus y. Dot x equals a and y equals b. Paren. Right? Now what?
P18.
Good. Now P.18 and we'll do the textual substitution, right? I mean, let's
P18 is.
With blah, blah, blah.
yeah, it will do P18 and TS all in one step. Okay, so we're gonna bring this down, right? WP, Ben, tell us what to do. WP dot x gets x plus y dot. Now, so what will this be? How do you do this?
Well, because you're doing textual substitution.
Exactly. So what are you textual substituting into what? You're taking
You're getting
this.
thing, and then you're replacing it with, yeah.
Okay, so what is?
Replaced by.
Well, let's
You
do.
already did it. So it's x equals a and y equals, and x minus y.
Yes, good. X equals a and
X minus y.
x minus y equals b. Does everybody see that? Are we good? And now, obviously, what do we do?
Now we do it again.
Do it again, right? So this equals by P18 and textual substitution. Well, no, let's do it. We can do this all in one. This and this in one step. So what do we have?
X equals
X plus y equals a.
X plus y.
Yeah.
Are you with me?
X plus y
x plus y equals a, and x plus y minus y equals b, which equals by some easy math, what? X plus y equals a, and x equals b. Now, I'm going to do,
And that is the weakest precondition.
well, I'm going to do a little, I think I'm going to do a little more simplification, because here we know that x equals b, so I think it would be help to have Gesundheit. So I think it would be, if we have x equals b here, I think we can put the b here and do some math, see? You know how substitution works? 3.84a?
Yep. An expression with some variable.
Equals this is the same conjunct with that, yeah. So I think it helps to separate out the y, the x and the y.
Okay.
So what we would have then is, so what we would have, this would be b plus y equals a, so y equals what?
A minus.
A minus b, and x equals b. And that is the weakest precondition. Does everybody see?
There is nothing weaker.
There is nothing weaker.
How would you find a stronger precondition?
Well, it would have to be a precondition that, well, you could always use false. Okay, are we good? Does everybody see how that worked? All right, now this next, okay, so now that we've done this once, I think we can be a little bit faster now. So let's do another example, and then we'll make a point. All right, let's say int x, y, const int a, b, another one. And then only this time let's do x comma y gets x plus y comma x minus y. And then post condition, no, it's easier, is x equals a and y equals b again. Now why is this one going to be easier?
You do it at the same time.
Because we do them at the same time, simultaneous.
Why are we doing this?
To make a point.
Okay.
With this one, we'll compare it with this one. Okay, so how do we find the weakest precondition? WP what? WP dot what?
Dot. That.
Dot, okay. Are we good? So obviously this equals by what? What's our little pattern here? P.18 and textual substitution. X plus y equals a,
And x minus y equals b.
and x minus y equals b. Okay. Now, well, but how can we do this?
Solve y.
Solve for y.
Solve for x.
Solve for x.
X, well, we know that x, yeah, let's solve this for, yeah, here, let's solve this for x. So this equals by, let's do a little math. Let's just do, I know it's trivial, but x plus y equals a, and x equals y plus b. Okay, so by 3.84a, substitution, right? What does that tell us?
Oh, do and math, so we can do it in one day.
And math.
Now let's do it.
2y plus b equals.
For this x equals y plus b, right? So let's solve this one for y. So this is y plus b. This is y plus b plus y, right?
Y equals a minus b divided by 2.
Y plus, only let's not do divided by 2. So this, because we don't like division with integers, right? Okay, so let's do this. Y plus b plus y equals a, and x equals y plus b. Is everybody with me on this?
More math.
Yeah, so this is 2y, so this equals by some more math. So this will be what? 2y equals what?
A minus b.
A minus b. Is everybody good?
You don't divide by 2.
And now what about this? let's multiply this by 2. Because we don't like to divide with integers because we have integer division. So let's make this 2x. So let's make this 2x equals 2y plus 2b. Now why do we want to do that?
Because it just looks ugly.
No, because we have a 2y here and we have a 2y here. So now we can use 3.84a and to get this to involve only x's.
Why are we doing this?
So that we can have x being one thing. We're solving for x and solving for y. Okay? So this equals by 3.84a. 3.84a. 2y equals a minus b. And, now what's this going to be?
2x
2x
equals a minus b plus 2b.
equals a minus b.
A minus b plus 2b is just plus b.
Yeah, so a plus b.
Do we want to keep the 2's?
No, we don't.
We have to. So 2y is a minus b and 2x is a plus
We
b.
refuse to divide.
We refuse to divide because we don't like,
Why?
because we have integer division in the program makes it, what if,
Oh, true, yeah, that'll just.
it will, yeah, it will. That's why we don't like to do that. All right?
My bad.
Okay, now here's the question. How does this compare with the other? I mean, is this the same? Is this the same as that?
It is. It is the same. Oscar's
It is not. Get a stupid answer. Okay. So here, let me scroll here. So note, so let's do some specific numbers. Note. Okay, so note, for a equals 9, b equals 5. For a, let's do some specific constants. For a equals 9, b equals 5, what do we have? What would the Hor triple be? So this would be x equals 5 and y equals
4. Work it out. Or do you want 9 minus
4?
5?
Wait.
Yeah. 9 minus 5
A-
is 4.
Yeah, I use 4. And then what was the statements for this? What were the statements for this?
Impromptu.
X gets
Something.
X plus 5.
X plus y.
x plus y,
Y gets
Y gets x minus 5.
x minus y. Oops, not. And then post condition was what? So that would be x equals,
A.
which is, in this example, 9, and y equals 5. Whereas the one that we just did was what?
we leave the 2x.
X equals what? What is the x?
You mean 2x?
2x?
7. 7.
Yeah, so x equals 7.
Wait, so we're not dividing by
Well, we are, but because I rigged it so that we could, so that it'd be even and we wouldn't discard the, okay? So x equals 7 and what? Y equals 2. And this time, what is it? X comma y replaced by what? X plus y comma x minus y. And the post condition is what? Same post condition, right?
Yeah.
Okay? So these are not the same.
Really?
Oh my goodness. That was your point?
I agree with you.
Okay.
Isn't that the only precondition?
I was gonna say,
It's the weakest precondition.
How's it the
Is there a stronger one that's not false?
Well,
There's not. I think it's the only in this case because there's no.
now how about z equals 10? And z equals 10.
That's stronger. Or is it?
So if you have more, if you just threw more conjuncts in there for no.
What if you just said, y is greater than 3?
That's weaker.
Is it
Isn't
weaker?
it?
Add more or stronger?
It is weaker. If you add more conjuncts.
Oh, that's a good question.
Yeah. 'Cause
Is it and or?
Strengthening.
No.
Is and. It'd be or.
The weakest. To strengthen it,
You add and.
you limit it more.
Yeah.
That was limiting it more.
Yeah. Weakening.
So I did that, it was strengthening
So
it.
you say and z equals 20, that's
strong, no, that's strengthening it,
What
isn't
if we said
it? Because we have an additional constraint on Z that we didn't have before.
What if we say or Z equals 20?
Oh, I don't think that, no, that doesn't, then it's not a precondition. I mean, then it's not a valid Hor triple, I think, right?
So,
Because we weakened it even further than what this is, and we know this is the weakest. All right, good deal. See you tomorrow.